Hi everybody, welcome to the Manifold channel. Today we're going to see how quickly Manifold can triangulate 5 million points. We're going to use the free Manifold viewer so anybody can try this at home and see for yourself how fast it works. We're looking at viewer. I'm going to click open a project, file, open, and here's a project called 5 million points. So we click open and bang, it opens instantly. When you have even very large projects, and this one was about 600 megabytes in vector format, they open instantly. And we can double click on the drawing and you can see that opens instantly as well. This is a drawing of 5 million points. And when I click on the contents plane, the components, you can see it's got 5 million records there. And as you can see, it's 5 million points that are in California, the state of California. These were created from a roadmap just to cobble up a data set of 5 million points that we can use for triangulation demos. And to see how to triangulate this, we can use the so-called transform panel. You can either use SQL or you can use these point-and-click transforms, which are kind of bundled transforms. Let's see how quickly it can triangulate. I'm going to click here on Triangulate All, and the moment I do so, Manifold instantly previews it. And it's actually doing a preview triangulation of 5 million points. It's that fast, literally that fast, that it can do a preview. It hasn't actually done the triangulation yet. It's just giving us a preview of what it's going to do. Let's zoom to fit. And Manifold is so fast that if we choose other transforms, for example, buffers, and let's do a buffer of, let's call it 5,000 meters, Manifold will instantly calculate those as well. It's a fully parallel product, so it can do this with just astonishing speed. And let's make this 100 meters, 1,000 meters. So as you can see, as we change it, it instantly recalculates all that stuff on the fly. And like I say, it's just giving us a preview. Previews are cool because they help us avoid errors when we see what's about to happen before we commit it, and that's very important when your time is valuable, when your data is valuable. So let's click back here on Triangulate All. Now, to actually do the triangulation and not a preview, I'm going to click Add Component, and it's going to start doing the calculation. I'm going to click Add Component, and there it goes. Now, what it's actually doing here is it's actually computing about 10 million polygons, and it's splitting them up into separate polygons and saving them as over 10 million records into a new data set. It's actually copying the data set and creating a new data set of 10 million polygons. If you try to do this at home, remember if you're trying to do this in ArcGIS or something like that, which has a way of doing triangulations where you're not actually creating separate polygons, you're just creating one huge multi-polygon, that's a whole lot quicker than separating out 10 million polygons and saving them as a separate polygon file so that you later have separate polygons to use for analytics. Now, while we're doing all this, let's talk about how parallelism works. And I've got some illustrations that I created in Manifold, which I'll pop open from a different session. And there it is right there. And if you have no parallelism, let's say here's the data. There's a bunch of cars that are trying to get somewhere. And here's the processor. It's like a gas station, which is doing something with the data. And here's where they want to go, which is the display or a location on disk or something like that. It's home. If you have no parallelism, you have all these cars, let's call it 8 cars, all have to line up to get onto a one-lane highway, and then one at a time they get to the gas station, where one at a time they have to wait to get gas. So that's a lot of time. That's like one core doing the work of what should be 8 cores doing. And then after that, they get back on the one-lane highway, and they got to get out to all these separate different destinations all at once. Now, people sometimes try to get around that by using what I call pretend parallelism. What they do is instead of having a parallel application, the application remains single-threaded, single-core, which is what's going on here. But the application calls modules, where the individual modules, like geoprocessing tools, for example, in Esri, might have been written so they can use more than one core. Well, the problem with that is you get this big bottleneck here. So all the data still has to wait to come off disk, one at a time, on a single-lane highway, where it goes through this, intersection that goes out one lane at a time to this gas station. Once they're at the gas station, yeah, they can use all 8 gas stations, but then they got to get back on that single-lane on-ramp to get back to the single-lane intersection, back to the single lane to get to the destinations. So if you have multiple steps, that can get really slow because you get a traffic jam at each step. I got to hurry up here because we're at almost at the 3-minute mark. Now, the way to get around such bottlenecks is to use true parallelism, which is what Manifold does. It's all cores all the time. So it's like getting on an 8-lane highway from the very beginning with all 8 cores being used to get the data, to do all 8 cores in processing to get all the way out to the destination. And if you have multiple steps, all those steps happen in parallel all the time. It's like getting on an 8-lane highway and staying on an 8-lane highway with no one-lane on-ramps or off-ramps. And let's see, we're about 2:41, so I think we're going to get finished here pretty soon. Let's go back here to this session. And this was cooking while we were doing all that other stuff. And there it's done. So let's see how fast that actually took. I'm going to Control L to get to see the log. And the log here says It took us 165 seconds. Well, that's about 2 minutes and 45 seconds, so that's not bad at all for our triangulation. And what did we create? Well, we created this drawing here. That's a triangulation all drawing, and that's over 10 million polygons. Let's look here in the component pane. It tells us, yeah, about 10 million polygons. And as we zoom in, we can see how fast Manifold can pan and zoom 10 million polygons. As you can see, this is done from a cold start, so we're not taking advantage of a whole lot of different caching or Windows caching or anything like that. It can pan and zoom these 10 million polygons pretty much as fast as we want. And let's do something interesting here. I'm going to turn these two guys off, and let's click open this map that I created earlier, which has a layer in it that has a triangulation layer. Let's toss in this drawing layer as well, so we have the triangulation drawing behind it. And let's turn on Bing Street Maps, which is a Bing Street Map layer that's brought in from a web server. And I'm going to zoom into here roughly to approximately to the San Francisco Bay Area. And let's reformat this a little bit. Let's start by reformatting the triangulation table so that it's so we can see through the polygons. I'm going to put a transparent color for the fill polygon so we can see through the polygon. And I'm going to make those polygons this pretty purple color. And now for this guy, for the triangulation layer, for the dots, I'm going to make the dots let's make them this pretty blue color here. And let's make them, I don't know. Actually, let's make the fill color blue. Let's make that color black, and let's make it 4 points in size. So we can see through the triangulations like that. We can see how incredibly fast this is as we go through it. Like I say, you can try all this at home. If you like, go to the Manifold user forum, which is at georeference.org. It's on the main Manifold website. When you click forum, and search for triang.zip, and that'll help you find in the forum the download for a 5 million point zip file, a shape file that's got all these 5 million points. So you can try the triangulation at home. If you try it in ArcMap, you'll find it takes hours in ArcMap, a little over an hour, and that's actually pretty good. Esri's very good software. It's not parallel, but it's good software, so it'll do it in an hour. Remember, this took 2 minutes and 40 seconds. And remember when you do this to do the triangulation, so you're actually asking it to split out those polygons and not just writing one super huge polygon, which doesn't do a whole lot of good for you analytically. If you try it with QGIS, you'll see it takes a little over a day. Exactly how long, I don't know, because I don't think anybody's actually been patient enough to report how long it takes. And if you try it in ArcMap Pro, ArcGIS Pro, then it also takes about a day, like QGIS. Now, I'm not bad-mouthing Esri or QGIS in any way. Those are absolutely fine software packages. They're very good, high-quality software packages, but they're not parallel, so they're not going to be able to do this as fast as Manifold. Basically, what those guys do for the most part is they use either zero parallelism or they do the pretend parallelism thing, which is what Esri's starting to do, where they're trying to make some multi-core geoprocessing tools. But every time that tool gets called from outside of the single core package, it has to go through that single core traffic jam to get anything done. And when you're doing multiple things at a time, which you often are doing in GIS, for example, grabbing the display and then showing the display, grabbing the data from off disk and processing and then showing it in a display, well, that really slows things down. So try this. Download Viewer. Viewer does an incredible amount of stuff. It's just almost unthinkable that it's free. It's fully CPU parallel. It's fully GPU parallel. It doesn't cost you anything. You don't have to register to download it. It doesn't time out. There's absolutely no advertising in Viewer whatsoever. There's only one spot where you'll ever see Viewer, and that's here in the Help About file, where you can see there's a commercial thing where there's a Buy Manifold 9 for those people that want to do it. And that's the only hint that there's any sort of commercial software that's in any way related to Viewer. Here, by the way, we can see what we're using. We're using an AMD FX 8-core processor. That's a very inexpensive processor. That's about an $85 processor these days on Newegg. So it's not like some $1,500 fire-breathing Core i7. It's a really simple, slow, inexpensive processor in a very simple and slow system. I hope you've enjoyed this tour. Download the data set, try it out, try Viewer out, enjoy it, and tell your friends about it. You can give it away for free as you like. And thanks for watching. Goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.